Could we do a gravitational slingshot around the sun? Is dark energy increasing or decreasing? And does stuff falling into a black hole get turned into dark matter? All this and more in this week's Overtime Question Show. Hey everyone, so summer hiatus continues, although summer sabbatical I think is a better term for it because we're doing a ton of work, but just sort of deeper work, more interesting, complicated work than doing a lot of live streams. So anyway, this week we got another batch of questions. Of course, these are the overtime questions. These are the questions that were asked during the extra portion of our Monday live streams. They're 2 hours long. We edit half of it down to make the weekly question show, and the rest just sits in our archives, and we bring it up for purposes like this. So enjoy another batch of our overtime questions.
Steve Chappell, is it possible to get a gravitational slingshot around the sun? Not to travel back to get humpback whales, but to reach the outer planets when they're on that side. How would the speed compare? So there is a special maneuver that you can do where you go down towards the sun, and as you get to the closest part of your orbit around the sun, you fire your engines. It's called an Olberth maneuver. And you get this multiplication of your engine firing for your velocity as you come out the other side of the sun. And like maybe that's what they were getting at when they had Star Trek 4, where they were going to try to go back in time, because that's like the fastest you can go, and you fire your engines as you're coming around. And the benefit you get is a much higher velocity. In fact, it's been suggested that really the only way to get the kinds of velocities that you want to be able to go to objects in the outer solar system, to get out to the Oort cloud, to the solar gravitational lens, is to use that maneuver. And the Olberth maneuver is really effective with solar sails. So I know this is going to sound really weird, but in fact, solar sails are a really good way to get very close to the sun. That, you imagine like a solar sail is just going to be pushed away by the sun by the radiation pressure, but that's not how it works. Solar sails are like all spacecraft. They're going to be in orbit around the sun. And then the direction that you tilt the sail depends on whether you're raising your orbit, you're moving away from the sun, or you're lowering your orbit. So you can turn it one way and the light pressure from the sun is raising your orbit. But if you turn the sail the other way, now the light pressure is almost like a brake, and your solar sail will spiral in. And the closer you get to the sun, the faster you're going to get. But the idea with this Olberth maneuver is you put your solar sail on a rocket, you fire it in a trajectory that brings it close-ish to the sun. And then the solar sail, as it reaches the closest point of the sun, unfurls the sail and then gets this enormous boost in velocity. And out you go out into the outer solar system. And yeah, you could use this as a way to get out to the outer planets, to get out to Pluto again, to get out to the solar gravitational lens, out into interstellar space. I like the idea a lot. Moon to Mars. So would everything that goes through a black hole be converted to dark matter? No. It's converted to black hole. Everything that goes into a black hole becomes more black hole. Matter, black hole. Energy, black hole. Antimatter, black hole. Dark matter, black hole. Neutrinos, black hole. Quarks, black hole. See where this is going. Anything that goes into a black hole just becomes more black hole. Weights. How has your perception of a relation to the universe changed as you learn more about it via Universe Today? It's interesting. I've been doing this job for so long, for 25 years, that I can think back to older versions of myself and sort of remember my state of mind about various concepts at various times in my career, about my understanding of the universe. And then the times when I learned more about the universe, more complexity, more depth, and gained more wisdom into the way things actually work, and was able to provide better explanations for what I do here on the show, but also in the reporting that we do on Universe Today and all of that. And so there's no one thing, but I can, if we pick any specific topic, I can sort of remember the evolution of my thinking about dark matter or dark energy or the electromagnetic spectrum or rockets. Like I can remember pre-Kerbal Space Program, thinking about how spaceflight worked, and then post-Kerbal Space Program, where I understood how orbits work in a deeper way. My time is spent with these little insights that build up over time as I learn more and more about this. It's a fascinating process to go through this. And I think it's something that you get. I mean, there's people who are watching right now who have been doing something for a long time, playing an instrument, doing some kind of hobby, woodworking, doing some kind of job that requires a certain amount of expertise, flying a helicopter. I don't know what it is that you do, but you all do things. And for the kids out there, you haven't been doing this long enough to experience that satisfaction about getting good at something over time. And yet it's such a wonderful experience. I've got to say that, I think it's probably, I don't know, it's like a meme, right? That wisdom feels good. And you wish you could go back and tell younger you the things you've learned so that they could, not waste time when you still had a young, energetic, healthy body, as opposed to an old man's body. But it is a nice advantage to getting old. So I there's like so much, and you can, if you go back to the early astronomy cast, you can hear my evolution week after week for 700 weeks, right? Where in the beginning, my questions are like, I am genuinely asking questions that I don't know the answers to. And the questions are kind of ridiculous, very science fiction oriented. And then over time, I'm building more of knowledge, and the questions I'm asking Pamela are getting a lot more refined, and that I'm more leading the conversation into the areas that I'm sort of producing the show as we go along, as opposed to just fulfilling my own curiosity. And that's how Astronomy Cast started, is I'm just fulfilling my curiosity, and she's teaching me. And after a while, I know the answers to the questions I'm going to ask her, but I know that you want to hear them because I can remember a time when I didn't know them. And so it's sort of like this pure form of empathy. So I don't know. It's a complicated question, right? Like, there's just so many factors to the universe. I find it also fascinating. I love becoming more knowledgeable and realizing how little I do know completely. So anyway, I know it's a kind of a rambling question, and I apologize. Gary Swift: many physicists believe that no matter how much you explain with science, there will be something beyond. Einstein, for example. Do you have an opinion on what is beyond a favorite theory? I don't know what it means to explain something beyond science, right? Because like the whole point of science is that you are using this methodology of inquiring into nature. You're forming a hypothesis, you're running experiments, you are attempting to disprove your own hypothesis, you are accumulating data, you are having somebody independently test the thing that you've done and to find out whether or not it's true. And if they can replicate your results, and if they can replicate your results and a third person, then this is part of just nature. And I think that we always go through this process where people have the things that they think are explainable by science and the things that are not explainable by science. And over time, the things that are not explainable by science become explained by science, that there is this growing cosmos of what science is capable of explaining as we gain more and more ability. And when a person says that they know something that is beyond science, then you have to ask this kind of epistemological question, which is like, how do you know what you know, right? By what method do you use to determine that this thing that you think is true? Is it objectively true, or is it subjectively true? And so I think that there will always be things that are beyond our current level of science, and they may be forever beyond our current level of science, but those things are real. Like just because we can't explain them doesn't mean that they're not real, and that there are things that people use to try to explain things, but they're not doing it properly, right? It's an opinion, it's a feeling, it's a hunch, it's a coincidence, whatever. And that's not science. So will there always be something beyond? Yes. I don't think there will ever be an end to science. I think that we will always be continuing to explore our universe, learn more at the large scale, at the small scale. And there are questions that have a scientific answer that I think we will never reach. Like, what came before the universe, right? Like, we may never know. We probably won't ever know what was here before the universe, because there's like no way to find out, because we've just got what's in our universe. How do we figure out the thing that was here before, if there was a thing before? And yet there is an answer, right? Something happened. And so there's going to be a whole bunch of those. And the problem is that we don't know which of the ones are the unsolvable questions, which are the questions that we could reach with the tools of science, and which are the ones that we could never reach. So it's fascinating. I don't have an opinion. I say we just keep looking at everything all the time. Goku-san, what do you think about Starship? The potential of a fully reusable two-stage rocket with a 9-meter fairing that can be sent to space purely based on the cost of the fuel itself would be an absolute revolution and game changer. One of the most important things that's ever been developed in the history of spaceflight. And yet, that thing has not done its job yet. And so we are at a point in time where we don't know if this crazy idea is actually going to work, and if it will ever be safe and reliable and work as intended, or it will drift towards the increasing amounts of complexity and engineering and cost that other rocket programs have. So it could be amazing, and it might be a lot more complicated and expensive and not fulfill all of our science fiction dreams the way we're hoping. Mark Scales. I read this week that some scientists have said the acceleration of the universe may be decreasing, and that eventually the universe might actually contract in the future. Is it plausible? I'm not sure exactly what you read, but I think this is in reference to the first data release coming from the Dark Energy Survey instrument, the DESI telescope. And this is a survey of the sky, a ground-based survey that is going to operate for 5 years and is measuring the effect of dark energy on the universe. And the assumption is that the amount of dark energy contained in every cubic meter of the universe is the same. That if you have more space, then you have more dark energy, but it doesn't change. And one intriguing possibility from the DESI survey is that dark energy is evolving, and it might actually be decreasing over time. And so that doesn't mean that the universe is actually going to contract in the future. It just means that we might not get that runaway acceleration of the expansion of the universe that we had been predicted by dark energy. But this is really early on. This is supposed to be a 5-year survey. This is the first year. And so it's too early. I think they were at like 3 sigma. And so it's just not enough to have a, to plan for your future on the contraction of the universe. But there's a lot of spacecraft that are coming. There's already the Euclid mission. There's the upcoming Nancy Grace Roman. There's Vera Rubin coming. And so with those 4, with DESI, with those as well, we're going to get some really solid answers about dark energy and dark matter in the next couple of years. Alan Barnes, could the Hubble tension possibly arise from errors in our parallax data influenced by gravitational lensing near the gravitational wells of the sun and the earth? Wow, that's a great sort of chain of thought here. So the Hubble tension, right? This is this mismatch in measurements of the expansion rate of the universe. And it is based on this distance ladder. At the closest area, we've got the parallax, which is like astrometry. This is what the Gaia mission is doing, measuring the geometry, the angles to a star when it's at one side of the sun on the Earth's orbit, and then when it's on the other side of the sun from the Earth's orbit. You get these triangles. You can measure, the classic examples, you put your thumb up and then move your eyes back, open one eye, close one eye, back and forth, and you'll see your thumb jumping back and forth. And so imagine instead of your eyes, you're the Gaia mission. And when it's your right eye, you're on one side of the sun. And when it's your left eye, you're on the other side of the sun. And the star that you're looking at, your thumb is a star, and you're watching that star jump back and forth in the sky. And so this is the foundation of the distance ladder. And then that was used to prove the Cepheid variables, and the Cepheid variables were used to prove the type 1a supernovae, and so on and so forth. And so if there's a problem in the parallax data, then you can't trust the rest of the distance ladder. And so no, I mean, this is the kind of thing that astronomers would be anticipating. Could the strength of the gravitational well that we're in causing a distortion of our view of the sky? No, but it's a sort of, it's great to sort of think about, like, so much of our distance measurements in the universe depend on these foundations, this foundation of parallax. And so the more accuracy that can be done with the parallax method to prove the Cepheid variables, the more the errors accumulate as you go through this process. VEQV. In terms of interstellar medium, wouldn't there be an average velocity for most debris so we could at least minimize impacts by traveling with the flow? No, I mean, the speed of the material in the interstellar medium is slow compared to a spacecraft that's going relativistic velocities. It's kind of like saying, as you're flying through a cloud of bugs, is there an average velocity for the bugs? No, the bugs are effectively at a standstill as it relates to your car that's moving at 120 kilometers per hour. And so, it's the speed of the car that's doing the damage to the bugs, not the average speed of the bugs. And the same thing. It's the speed of the spacecraft that's crashing into a grain of dust at half the speed of light, not the grain of dust's speed. DC, is it possible that dark matter could be explained by black holes affecting the rest of the universe, or many tiny black holes instead of a dark particle? Absolutely. One of the proposed theories for dark matter is that it's made of primordial black holes. But you can't get that kind of black hole in any way that we understand in the universe today. So they would have to have been left over from the formation of the universe. That you would have had to have gotten black holes formed within a few hours after the universe itself formed. And then those black holes would just be roaming out in space. And you could absolutely explain the presence of dark matter with those black holes. But then you would also have to know that primordial black holes exist, which would be pretty weird. J, is there enough mass in our solar system to theoretically turn the sun into a black hole? So the sun will never become a black hole. That it doesn't have enough mass when it dies to have the implosion that you get a black hole from. But is there enough mass in the solar system to theoretically turn into a black hole? Sure. If you had a way to compress all of that matter into the right density, it would be a black hole with the mass of the entire solar system, which is the mass of the sun. You could turn your house into a black hole if you could compress all of the particles in your house into a small enough volume that it would have a escape velocity that exceeds the speed of light. So a black hole is really just about getting matter and energy close enough that you get a gravitational field that you can't escape from. Apropos of wet snow, if we redirect asteroids into Venus and somehow drastically increase its rotation, do you think this would re-trigger the dynamo effect and potentially reintroduce a magnetosphere? I don't think that you could get a dynamo going on inside Venus purely through increasing its rotation speed. And I don't know whether you would get that by crashing out. Like, I can imagine that you would crash asteroids into Venus one at a time. They have to be really big ones because they have to get through the atmosphere. So, kilometer class asteroids crashing into Venus one after the other. So I don't know if there is a connection between the rotation speed of Venus and whether or not it's going to get an internal dynamo. There's kind of two, and I forget the technical term for this, but the gist is plate tectonics or no plate tectonics. The stagnant lid, that's it. So the thought is that with Earth, we have this lighter crust that floats around on top of the mantle, and you get the plate tectonics, but also this means that you're getting this sort of release of energy coming from the inside of the Earth, and it is helping to lubricate the core that's allowing it to rotate, and you get this internal dynamo. And that for whatever reason, this process just never happened on Venus, that it doesn't have plate tectonics, that it, instead of having this kind of steady release of heat through the crust, lava going out into space, the crust is sort of complete, and instead the pressure builds and the pressure builds, and then at some point the entire surface of Venus inverts and you get the whole thing is covered in lava, and then it hardens up, and then it sort of starts all over again. And it could be that Venus used to have plate tectonics like Earth and now it doesn't, or it could be that it's always had this stagnant lid. And it might be that Earth had a stagnant lid for the first, say, 800 million years or so of geologic history, and then developed plate tectonics over time. So something made Venus go horribly wrong, and that's why there's all these spacecraft planning to go to Venus. But to make Venus better, really the thing that you need to do is you just need to decrease its atmospheric density. And the way you do that is you cool it down. You put a sun shield in between Venus and the sun at the Venus-Sun L1 Lagrange point. Shade Venus. Venus cools down. It cools down so much that the carbon dioxide falls out of the atmosphere. It snows out of the atmosphere. And now the atmosphere is not as dense. Then you have to figure out some way to lock up all of that carbon before it puffs back out into the atmosphere as soon as you let the heat back in. But if you can do that, if you can pull that off, you block the light, cool it down, lock up the carbon, then you could sort of tune Venus to make it as habitable as you want it. Do supergiant stars have sunspots? Would they be supergiant as well? Yeah, they absolutely do have sunspots. In fact, like Betelgeuse, for example, it has sunspots, or, star spots, but they're in some cases gigantic. So it has these enormous convective cells that can be like 60% of the surface of like the star that we can see. So imagine Betelgeuse, it's already out to the orbit of Jupiter, and then one big blobber of it is a giant sunspot. And that contributes to a lot of its variability. So, yeah, they are super giant, and they are like super duper giant, even compared to the size of the star itself. Nostalgia Arcade. What is your opinion, feelings about UAPs and freaky phenomena in general, like Skinwalker Ranch? So, like, I'll be honest, I have no idea what Skinwalker Ranch is. I don't get that channel on my Netflix, or my YouTube, so I have no opinion about that at all. I know, a lot of people that I respect think that everything freaky that they see is easily explained by various phenomena. So UAPs, I mean, it's right there in the name. They are unidentified aerial phenomena. So, if I could say what I thought they were, then I would have identified them. They'd be like Fraser identified objects, FIOs. There you go. So if I had a feeling, like literally anything about them, then they would turn into FIOs, right? They would no longer be UAPs, and they would turn into Fraser identified objects. And so this is the problem that we have, is that they are unidentified, that many have ended up being balloons or birds or other aircraft or things that are perfectly explainable. And so if a person has any kind of explanation for what these things are and what they do, then they have to present them. They have to present this evidence. And it can't just be, I don't know what it is, I don't get it. So aliens, right? No, it's not. It doesn't work that way. You got to unidentified, and then you just have to stop and wait patiently, checking your watch every now and then for more evidence to show up. And if no evidence ever shows up, then you just move on and go, well, no evidence ever showed up. I'm going to go watch something else. Dave Duell, big fan, finally catching you live. Why didn't the late heavy bombardment create a water world on the moon? So it could very well have added a whole bunch of water to the moon. It's just that the moon, because it's so small, lacks gravity, has no atmosphere, would have lost all of that water to space from the sun within like 10,000 years. So not very long. And so since 10,000 years is dramatically shorter period of time than the billions of years that the moon's been around, the moon probably did. There was probably a time when there was water on the moon delivered by comets, asteroids, whatever. But at the same time, the sun was hammering it with its radiation. I wonder if there was like an atmosphere on the moon at some point in the early history. It's kind of an interesting question, that there was just like enough volatiles on the moon that it was able to keep its water for a bit, keep its atmosphere for a bit, but it just couldn't withstand the sun. And so it was gone. You know, people always ask me like, oh, would it be cool to terraform Mars or terraform Venus? Like, that'd be fine. Sure, why not? But no, the thing that I want to see terraformed is the moon. That all you have to do is just deliver 1 atmosphere's worth of gas to the moon. And it's a small object, so it doesn't have to be a gigantic atmosphere. And that you could be walking around on the moon. You could be breathing the atmosphere. You'd be protected from the radiation of space, partly. And it would be warm enough to have water on the moon. And all you'd have to do is just keep that atmosphere replenished, because the sun is going to keep trying to blast it away into space. And it's close. Wouldn't that be cool? Bucko. So Fraser, we can't see a black hole. So what would one look like? I'm still a bit confused. Well, like, you can't see a black hole. It's like the definition of a black hole is that nothing, not even light, can escape a black hole. And so if you tried to look at a black hole, then all you would see would be the distortion of space behind the black hole, right? That you would be seeing like a lens moving through space, the size of the event horizon. You see distorted light that's coming from behind the black hole, that's being wrapped around the black hole by the gravity of the black hole. And then you're also not seeing the starlight that's falling into the black hole. It is emitting nothing. So you don't see anything. Now, you know, you probably saw Interstellar, and you've seen, they had one in that Zack Snyder movie I was mentioning, Rebel Moon. And so, you know, if you've got a black hole that is surrounded by a bunch of material with it falling in, you're going to get like the accretion disk around the black hole, and you're going to get this weird distortions of it. But if it's just like a straight up stellar mass black hole just floating through the universe that has no accretion disk, then you won't see it. You'll just see this distortion of the stars in the sky where the black hole is, but that's it. Daniel Stevenson, how is it possible to land a robot on a hurling asteroid, collect core samples? It's tricky. So think about, say, the mission that was able to collect a sample from asteroid Bennu. So the first thing that you do is you match the orbit. When OSIRIS-REx went out to asteroid Bennu, it had to match the orbit of Bennu and go into orbit around asteroid Bennu. So then you sort of like imagine you're only focusing on the asteroid itself. And then it had to match the rotation. So Bennu is turning. And so the spacecraft had to match its orbit around Bennu so that as the asteroid was rotating, the spacecraft was orbiting around with it. You've now sort of removed the spinning asteroid part of the equation. You've removed the going around the sun part of the equation, and you're just getting closer and farther to this asteroid. And that's what it did, is it just slowly, carefully let the gravity pull it closer and closer to Bennu. And then it touched, fired its retro rockets and touched gently into the surface of Bennu, even sunk down a little bit into it, and then kicked off the surface, collecting a bunch of samples, and flew back to Earth. RJQ, what question do you really hate answering? It's going to blow your mind, but I don't hate answering any question. So, like, I don't like answering questions when the person isn't being honest and like cares. And so if a person rolls their eyes and goes, what makes you think that astronauts can really pass through the Van Allen belts? I don't like answering that kind of question. So I don't like answering questions from people who are not asking questions in good faith. But any other question, like honest questions from people who want to know more about the cosmos, I can't get enough of it. I love it. So, yeah, I have no problem with any of it. It's super fun. And I have answered the same question many times, but also there's a certain beauty and efficiency in practice. And so every time I answer the same question, I'm thinking about the last 3 times that I answered that question, and what were the parts that I thought were sort of a little kludgy and maybe I could do a better job this time. So no, I love it. I love every part of it. I I'm I'm so grateful to have this outlet to answer questions, because otherwise I just inflict this on people in my vicinity. And so this is like, this is a get out of jail free card for me to just, explain things. So yeah, this is the best. That's like the hardest thing that I had to learn how to do, was to not start explaining things at the drop of a hat when people ask questions, or even like, so now I sort of keep my mouth shut unless someone asks me. Phil Forrest, should schools stop teaching that gravity is a force? No, it's fine. I mean, I think, we learn abstractions all the time about things. And so to learn about gravity and to learn how it works as a force I think it's perfectly fine and viable. And like later on, if it's really relevant, you can teach people. But like, what is a elementary school kid who's like doing simple experiments with ramps and cylinders rolling down ramps at different rates going to do with a teacher explaining to them that really what they're experiencing is a curvature of space-time as defined by Einstein's general theory of relativity, and give them the relativistic equation so they can try and calculate this kind. Like, it's too much. So the simplicity of gravity as a force, it worked for Newton. It can work for kids, and then later on, if they want to go further, then they can. But no, I think we can sort of give people the level that they're ready for.
Now, I'm going to talk about a show that everybody has been recommending that I watch, and I finally watched it, Scavenger's Reign. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Bill, David Giltonan, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Zeppelin, who support us at the Master of the Universe level. And all of our patrons, all your support means the universe to us. So I've had a lot of people in the comments asking me if I've seen Scavenger's Reign yet, and I hadn't watched it during when it was on, but I finally got around to watching it. And wow, what a show. So for those of you who aren't familiar, it's an animated show about a bunch of astronauts who are marooned on this alien planet. And the planet is so bizarre, and the life on this planet is really weird. And each of the groups that are stranded sort of in different parts of the planet are trying to get back to the main ship. And as they do, they encounter these strange life forms, and they have to sort of come up with clever ideas to either use the life forms for various purposes like transportation or food or protection. And then in other cases, they're very dangerous, and they have to figure out how to deal with them. So I can't, if you ever read like the Heavy Metal comic books or like watched the movie Heavy Metal, how it's sort of this weird, surreal French animation, it's like that. Really interesting, really good, really well done. And the creativity of all of these aliens, I've never seen anything like it. So if you want a cool show, check out Scavenger's Reign. All right. Thanks everyone who recommended this one, and we'll see you next week.